When we simulate a crane or vehicle movement using moving load, there might be some warning related to the generated load. It's very common during first few iterations. But this doesn't always mean there is some problem in the model. There are few warnings which we can easily ignore depending on the load condition. So it is important to review this warning first and then decide whether to ignore it or rectify the model. Hi, I am Surajit Ghosh, and in this video, I will talk about a warning that is reported during moving load generation and discuss how to interpret this warning for further action. If you are following this series on moving load, then probably you have noticed these two warnings. First one was reported when we have applied a crane load on a gantry girder. During moving load generation, program encounters a problem. There was no member present in the specified Y level. Hence, no load was generated. Reason of this problem and how to rectify it, that I have already covered in part 5. You can check that for more details. In this video, I will discuss about the second warning, which is very common during load generation on any bridge deck. Consider this model, which I have used in part 3. On this deck, I want to simulate a truck movement using moving load. Under vehicle definition, wheel load, axle distance and width of the truck has been defined. First wheel load refers to the load from the rearmost wheel. Next, we have generated 33 load case to apply the wheel load on the entire length of this deck. Initial position of the vehicle is defined based on the location of the rear right wheel of the truck. All these details are covered in part 3, so I am going to skip this. After analysis, we can notice that there are 10 warnings, which we can review directly from the output file. These warnings are related to the moving load. There are few generated load cases where the wheel load is applied outside the deck, beyond the X and Z range of the structure. Relevant load case number, wheel number which is outside the boundary, and total number of wheel is also reported. Finally, there is a note which indicates there are more warnings. Only first 10 are reported here. Rest are skipped. Let's review the first warning. It is reported for the first generated load case. Wheel 1 is outside the structure. Similarly, wheel 2 to 4 are also outside the deck for this load case. 4 out of 6 wheels are ignored during analysis. Does this mean there is a problem with the moving load definition? We can review the first position of the vehicle from the load page. This is displayed with a red line. Arrow indicates the direction of movement, and this red box defines the initial position of the vehicle, which is the location of the rear right wheel. Wheel number is counted from the reference point towards the front, so these are wheel 1 to 4, which are obviously outside the deck. Only the front wheel load is applied on the deck, and rest are not in contact with any part of the structure. Hence, these warnings are reported. This is not an issue. During load generation, we have deliberately defined the vehicle position in such a way that the front wheels touch the extreme end of the deck. When a vehicle moves on a bridge, for structural analysis and design, its journey starts when the front wheel enters the deck and ends when the rearmost wheel exits the deck. We have already discussed this, and based on this logic, we have defined the location of reference point in such a way that the front wheel load is applied on the boundary member of the deck. Rest of the wheels are outside. Rear wheels gradually enter the deck in subsequent load case. For load case 2, front wheel moves in the X direction by 1 meter. Still, last 4 wheels are outside the deck. So 4 more warnings are reported for load case 2 for wheel 1 to 4. If we check the wheel position for other generated load case, we can notice that only under load case 9, all wheels are inside the deck and 6 wheel loads are applied at relevant location. Till load case 8, one or more wheels are outside range. Not only this, when the vehicle exits the bridge after load case 25, front wheel loads are applied beyond the structure. From load case 26 to 33, this will also generate same warning as wheel 3 to 6 are outside the deck. These are not reported in the output file. This is the meaning of this warning. Now the question is, should we worry about this warning? For this load condition, we have deliberately selected the initial position and load generation number in such a way that few wheel loads are outside the range. So we can easily ignore this warning. During analysis, program simply ignore this extra load outside the deck and there will not be any effect on analysis and design result. No modification is required. Only if all wheel loads are applied beyond the range, then we need to rectify the model as that load case doesn't have any meaning. For example, consider this model. I have generated a moving load with same load data. Only difference, this time I have defined the initial location of X incorrectly. So it is far from the deck, and for the first few load case, this vehicle doesn't enter the structure. All wheel loads are applied outside the deck. In the output, we can notice that for the first load case, all 6 wheel loads are ignored. This is not correct, and we need to rectify this model. Also, it might happen due to incorrect reference point, load generation will stop before it enters the structure. Moving load analysis will produce zero analysis result. Another condition, if the generated load number is higher than the required, say 50 for this model, then for last 17 load case after load 33, all wheel loads are applied beyond the deck. This type of irrelevant load case will increase the analysis time without any impact on result. Also, if we combine the moving load with other gravity and lateral load case, this will increase the overall load count. Hence, any unnecessary load must be removed from the model. I always recommend to check the load position for first and last few load case to confirm whether the load application is proper or not. Accordingly, we can ignore the warning or rectify the model. That's all for today. Thanks for watching.